Now, before you start implementing some quality management system in an agile environment, you have to have a look at what kind of decisions are you going to be making. Now, the decisions are largely you're going to be tailoring the quality management system rather than reinventing it. I mean, nobody wants you to reinvent the entire quality management system because it's taken a long time to learn what actually works. So we don't want to try and reinvent it, and we don't want to throw everything out. But what we do want to do is enable the system to make intelligent choices about what we do throughout the production process. So most quality management systems are robust and better than no quality management system. And we know this. I mean, there's something that's fairly basic in quality management production. Almost anything works better than nothing. But the existing quality management systems, the ISO 9001 quality management systems, are devised for and suited for a divisionalized organization. That is, you've taken job specialization to such a level that you have people sitting in divisions, and the production is managed across the divisions, and you get matrix organizations and things like that. So the organization itself was set up for this divisionalized production of things. Now, it's not easily used. The traditional quality management system is not easily used in a multi-skilled self-managed team, which is what a lot of organizations are moving toward now. The move is much more toward self-management and self-control because people are becoming better skilled at their jobs and more knowledgeable. And that's fine. But now we're starting to get very accustomed to these self-managed teams, and we want to actually improve the performance of them, improve the quality of their outputs. So we've actually got to do better than just, muddling through in an organization. So it's mostly a problem of preventing waste. That is, say, wasting resources, rework, remediation, that kind of thing. And also tailoring the process. The processes may be too formal, you have to loosen them up a bit, or they or not formal enough, in which case you have to tighten them up, or the practices you use could be inappropriate. Now we'll come around to the difference between the processes and the practices later. So one of the decisions you have to make is what qualities matter. It's pointless to try and say, well, we have everything, because some of the qualities do contradict each other. If you have high performance, you really can't have high modifiability, because high performance means you, particularly in software development, you have basically spaghetti code as the fastest that anything works, but it's very, very difficult to maintain. Now, organizations are beginning to discover that maintainability is probably one of the major concerns of their software systems. So you will need some form of modifiability. Similarly, security and modifiability do contradict each other because for security you want something locked down tight, and modifiability you don't. Usability is also contradicting security, because usability, you're talking about things like access and ease of access, and that means you have to have some level of accessibility into your system that probably exposes you to some security vulnerabilities. Now you've got to trade these things off. So the first level of decisions you have to make for your quality management system in the circumstances is which qualities do you want? Which qualities matter? Now that depends on the stakeholders, and for that you generally need to ask the stakeholders, and the stakeholders are the customers and the business owners and the development team and everybody else who's involved in it. There are some standard ways you can determine who the stakeholders are and what their interests are. So I won't cover that all here. Now, if you can't ask all the stakeholders, as you may not be able to in some circumstances, you can make reasonable guesses. The next decision you have to make is on the level of rigor, because more rigorous requirements demand higher quality assurance outcomes. Now, by level of rigor, I'm talking about, is this a life-critical system? So is somebody going to die or be severely injured if this fails? If so, you'd better have your quality pretty good. If it's merely a matter of, well, somebody be inconvenienced, you probably don't need that much rigor. If this system you're building is simply a tryout system, a small demonstration, then basically the level of quality doesn't matter that much as long as it demonstrates the functionality. But personally, if you're talking about things that are going to be critical to life, medical systems, aircraft control systems, increasingly autonomous vehicles, or a number of the decisions that make financial decisions on our behalf or that affect us. These things are quite critical, and you will need to know the level of criticality that you need. So the level of rigor that the system has to be produced under. Now, aside from the rigor needed in the produced product, you have the makeup of the team. A small team doesn't need a production system and a quality management system that is quite so rigorous, simply because a small team gets to talk to each other. In a large team, it's not possible to talk to each other, and there's a certain amount of communication by handoffs. Handoffs meaning, I write something down, I hand it to you, or I send you an email or something like that. Now, these means of collaboration are a bit more error prone than if I'm sitting there talking to you and can clarify it there at the time. So the nature of the team or the size of the team matters as well. The teams themselves, if you have a highly experienced team, they kind of know what they're doing, and you don't need a production system and a quality management system that is quite so restrictive. If, on the other hand, you have a team that is not so experienced, then they need to be supported by processes that essentially tell them what to do and constrain what they can and can't do. And similarly, if you have a highly distributed team, your collaboration needs to be pretty good. Now, for example, if you've outsourced some of the development somewhere and you have no visibility into how they are developing the software, then you probably need to go test it pretty well when they come in, or when it arrives, and that needs to be fairly rigorously tested. But if that outsourced team is keeping you fully informed of the development and the testing they've done, so essentially they're keeping you appraised of the quality of that output, you don't need to test it so much when it gets there. Now, in all of these decisions, what you're trying to do is to reduce the level of risk as fast as possible. I mean, all projects start out with some risks, and some of them are going to be pretty high risk comparatively. Now, the whole point is to reduce that level of risk as fast as you can. So in novel situations, uncertainty and ambiguity are very, very high. No one knows quite what to do or how to do it. Now, in those situations, you need to get some pretty expert people in to have a look at what they can do and let them do it. In these situations, experts use their judgment. Right? But as experience grows, we gradually learn what to do, and so we can routinize what we're doing. We can make it a bit more formulaic, and we can tell other people, and so they can learn from what we've done. This is called lessons learned. But either way, the whole idea is to reduce the level of risk as fast as is possible.